Hi friends, this is Jason here. Today I am going to introduce you one transmitter. This is a multivariable transmitter. This has multivariables like temperature, differential pressure, static pressure, like that. So you can see the range of differential pressure and static pressure and temperature ranges, and the output will be 4 to 20 milliampere as common as all transmitters. So the ranges will be vary according to the requirements of the customers. So we can change it in the program also with using a 475 communicator or any latest trucks hard related communicators. So here it has the maximum working pressures and or other details like supply and all things. So mainly it have differential pressure and static pressure and one more temperature connection. So this is the temperature connection for this. Here we can connect the temperature element. So this the cable is for that, to extend that much long if you want anything long like that. So it has a manifold in down. It has a differential pressure lines. So you have one positive line and negative line, and two drain valves, and this is an equalizing valve in the center, and two isolation valves in the middle side of two valves. You can see the big valves are the isolation valves, and the last two small valves are the drain valves, and the middle one is the equalizing valves. So I think you may know the connections to make valve opening and closing as common use. So further I will explain you how to connect to calibrate and to change the PV variations, and how to take the measurements. I will show you in the further. So keep watching if you need to know about more. So here we are using a 475 communicator and a multifunction variable calibrator for supplying the temperature supply and the power supply as a 24 volt. This all we are giving, and we are giving pressure by our base 5000 controller. So here I made all the connections. So actually I make the video in my lab and I'm recording in my home. That's why little bit mismatching you may feel. So I'm sorry for that. This is the connection I made for temperature stimulation. When we will connect the loop, then only it will show the full options. It will show the full options in the 475. Then only we can change the PV. So here I connected all the variables and completed the loop. And the temperature you have to give 4-wire connection. So you have to go as normally, go online. It will take little bit time to communicate with the transmitter. So make sure the power will be on 24 volt and there is no short circuit, and all be confirmed that before going for the calibration. Make sure the isolation valve should be open and the equalizer valve should be open, and all valves should be open, and it should be kept a little bit 15 to 30 minutes in your room temperature, means it's in your lab temperature. Please make that sure. So here we are connected, and you can see the online details. It's in lb per second. So we have to change the variables. So now it's in the flow measuring unit. So we need to change the variable to take the readings. So we need all the variables like differential pressure readings also we need, that have a corresponding 4 to 20 milliampere, and the DP static pressure also have individual 4 to 20 milliampere output, and temperature also it have that separate milliampere output. So we need it both. So we have to select as the follow, individually and calibrate individually and take the milliamps individually. So here I will show you how to select and change the PV. Okay, here I selected differential pressure as the present value, means PV. So you can see it's dP, absolute pressure, temperature, gauge pressure, flow and flow total. Okay, so here previous it is flow total. So here I have to check individually. So I am selecting here first. I think I selected PV as differential pressure. So let me check how the video goes, because it's recorded earlier, so I am giving audio for separate, that's why a little bit delayed. So if you have any queries or if you have any doubts, you can ask in the comments. So usually I won't get that much time to get regular updates and uploads for the videos. So that's why if I am getting free, so if it is informative, so I am getting it for you guys. So it will show like this error messages. So it's not the error, it's just warning message. So it's just saying the PV will be changed as previous one, like that. So it's get it okay, no problem. The PV has been changed, so we have to save it, and then the PV will be differential pressure. So you can see the previous it is total flow, so it is changed to differential pressure, and it is showing the unit as inch H2O, and the milliampere is 4.09 milliamps. So like that, then I have to give the differential pressure from the manifolds, and I have to give the 0 to 100 ratio, 0 to 100, and I have to take the milliampere output as corresponding to the differentials. Then I have to go for another variable like a static pressure. So here I will change to temperature. Here it came temperature. So this is some error messages, so you have to ignore that, no problem. So here I selected temperature, so it's in degree Fahrenheit and it's showing the corresponding milliamps. So with the temperature I am giving it the temperature from my multifunction variable it's a multifunction calibrator. So I am stimulating with that with the 4 connection 4 by RTD. So you can easily connect to maximum and 0. So you can take the corresponding milliampere correction. If you have any error in that at that time, the same PV selection you have to calibrate it as 0 calibration or higher and lower calibration you can do. Okay, so like this you have to do all the variables individually. Okay guys, thank you for watching. If you have any queries and you have any needs to know about more about instrumentation and calibration, so you can comment in the comment box. Okay, thank you.